Since its inception in 2008, blockchain has been touted as the future of money, the answer to sustainability problems, the toughest tool in the security arsenal. But critics think that almost every use case for blockchain can be achieved through easier and cheaper means.
Some people believe in blockchain and really think it will change the IT. And other people say it's exactly the opposite. It won't change anything. It doesn't add any real value to it.
I believe it will grow tremendously. If there's a need for these features, blockchain is not the answer for every use case.
In today's episode, we investigate the blockiest of all the chains, the most distributed of all the ledgers, that is blockchain. We find out what gets some people so excited about what, to me at least, just looks like a flashy database, why so many organizations' blockchain projects never make it past the planning stage, and who is the mysterious creator of blockchain. Okay, we don't manage that last one. Some of that and so much more. I'm Michael Bird, and this is Technology Untangled. Thanks to the perfect storm of slow news cycles, big marketing budgets, and Elon Musk's tweets, blockchain has been hyped beyond belief. And it's also been made way more complicated than it needs to be. To find out more, I called up Eng Lim Goh.
My name's Eng Lim Goh. I'm Senior Vice President and Chief Technology Officer for Artificial Intelligence at Hewlett-Packard Enterprise.
So first question then, what exactly is a blockchain?
Let's start with a public blockchain first. Let's use an example of an analogy of a ring binder. You've got this notebook with many blank pages bound by a ring binder. On page 1, you record a number of transactions. Maybe Jim pays John 2 Bitcoins and Sarah pays Jim 10 Bitcoins and so on and so on. Then on the next page, you have the same, again, set of transactions being written down on it, and the next page, and the next page, and so on. So if you imagine each page is a block, and all the pages are bound by the ring binder, being the chain, you actually have a blockchain there, right? So that's what a blockchain is, except for the fact that in a public blockchain, this ledger or this record, right, this chain of pages or chain of blocks is digital, and is distributed to everyone publicly, equally publicly, with no central custodian.
Why would you want to use a blockchain?
There are two major reasons why you want to use a blockchain. Right? First and foremost is when you want to keep a record of an entire sequence of transactions, especially if you want it to go back all the way to Genesis, to the beginning. And secondly, you want that record to be transparent. That is, you want to decentralize it by distributing copies of the same sequence of records to everyone equally, with no central custodian. And within that, therefore, how do you then deal with the fact that with everyone having a copy, how to have anti-tampering capability? And this is where you would apply a cryptographic hash. And finally, within transparency, how do you then make decisions if everyone is equal in this sense, right? In a public blockchain, they have a cryptographic puzzle to solve. And if your application has a need for any one of these capabilities, this is where you would use a public blockchain.
Now, you might deduce from the phrase public blockchain that there is, in fact, also a private blockchain. And there is, but we'll get to that in just a minute. First, to understand why people are so excited by blockchain, there's no better example than the world's most famous use case, cryptocurrency. And the world's most famous cryptocurrency, Bitcoin. In 2008, a white paper called Bitcoin, a peer-to-peer electronic cash system, was published by an elusive person, or persons, under the pseudonym Satoshi Nakamoto.
The paper was published in 2008, and then Satoshi mined the first block, the Genesis block, right to the beginning, called block 0, in 2009. And after mining that block, he was awarded the very first and therefore created the very first 50 Bitcoins. And then in 2010, December 12, 13, he, she, or they went quiet, and it has been quiet for more than 10 years now. So that was how it started.
And what was so revolutionary in the way that Bitcoin was set up?
It is applying the idea of public blockchain to financial transactions and the implications that comes with it, right? If you look back at the 2 points, is a record of entire transaction sequence going back to Genesis. Imagine now having financial transactions that you can trace back all the way to the very beginning, time-stamped, marching forward in time. And it is transparent, meaning everyone can have a copy to look at all the transactions, albeit that there is privacy associated with the entities making those transactions. And there is no central custodian. And in order to make decisions as to what transactions are valid, there is this competition. Why? Because there is no central custodian to make that call. Therefore, you need a consensus to be reached as to what transactions are valid. They have to have a competition to solve that problem.
You'll hear the cryptographic competition referred to as proof of work, or for Bitcoin, its most common moniker, Bitcoin mining. Now, miners all compete by using their compute power to try and solve a complex hashing problem. And for Bitcoin, they get paid in Bitcoin. Sweet. Once the problem is solved, the transaction or block is added to the blockchain.
And then finally, because everyone gets a copy, how do you make sure, as like in a financial transaction, that no one tampers with it if everyone has a copy of it, right? The answer is the cryptographic hash. Right, if you go back to the analogy of the ring-bound notebook with all the transaction on each page and therefore each block, at every page, you can use a cryptographic hash to consume the entire page of text transaction on that page, right? And then produce you a 64-digit hexadecimal number.
The cryptographic hash is what makes blockchain impossible to tamper with or immutable. And if anyone changes the information of the block, the hash that is output will be altered. But it doesn't stop there.
After that, you take the cryptographic hash of each block and then hash them again to get a overall hash number, 64-digit hash number. So that if anyone touches any block in history, it would change that block's hash. Therefore, it will also change the overall hash, and you will know it. This is how they ensure that in a public blockchain where everyone has a copy of that entire chain, entire history, that they ensure that there is this anti-tampering capability in it.
So for a quick tally of some of the main benefits of this public blockchain. Number one, it's immutable. It can't really be tampered with, modified, or manipulated, therefore it's really secure. Number two, it's totally decentralized. There's no central authority or single central platform that maintains the network. Every user has a copy of the blockchain ledger, making it totally transparent. Number three, it can scale. Just look at Bitcoin. It's the best known version of a public blockchain, and its popularity kind of comes down to it being the earliest and most trusted. And thanks to the way it's taken off, we've seen just how well a public blockchain can work at scale. All right, so with that in mind, what's all this public-private business about?
What I've talked about is what a public blockchain is. In a private blockchain, you still have the record of the entire sequence of transactions going back to Genesis if you want to. In the second part about transparency, where in a public blockchain, you decentralize by distributing copies to everyone equally. In a private blockchain is where it is different. Here, you decentralize by distributing copies to every member in that private club, so to speak. Yeah, that's why it's called a private blockchain. So what you have is one additional layer where membership is being approved, and those who are part of the membership will be given copies of that blockchain. That's the key difference, where in a public blockchain, everyone can have a copy of that chain, and in a private blockchain, only certified members are given a copy of the chain of blocks.
Do industries who are using blockchains, do they mainly use private or public blockchains?
Most of what I've seen are private blockchain, mainly because in industry, they typically transact with known members, like in a supply chain or like in financial institutions to financial institutions, where they know clearly who the other party is. And if they want some of the other features of a blockchain, they will use a private one because they want to keep the records amongst themselves, amongst that membership. So private blockchain is a more common one in industry.
So whether you use a public or a private blockchain really depends on the type of transparency you're looking for.
You need it to be transparent to everybody. There are times in your application you may not want that. There are times where you want a little bit more privacy, where you say, I would only want the transparency to the certified members. There are even times where you want to go even further with your privacy to say, I don't want even members to see it. I want only a central custodian to see it and control access to it. And therefore, you won't even have a private blockchain there. You will end up with a centralized ledger like traditionally what we have before blockchain came along. And therefore, given transparency, whether you need it full, partial, or totally opaque, or transparent only to a custodian, you bring in the need for anti-tampering capability and also bring in the need for decision making. But the more centralized and more private you go, right, the less of an overhead required for anti-tampering, because if you have a central custodian at the extreme, the central custodian is responsible for keeping the records' integrity intact. And then if you have a central custodian at the other extreme, decisions can be made there without having to have the competition, like the opposite extreme where in a public blockchain, you need a competition.
The reason why cryptocurrency's energy consumption regularly makes headlines is because of the proof of work. According to the University of Cambridge, Bitcoin mining uses more electricity annually than the whole of Argentina. What? And get this, some estimates suggest that one Bitcoin transaction uses the same amount of energy as 100,000 Visa transactions. Let me tell you, energy efficient it is not. And because of that, alternatives are already being looked at.
There are coming up with variations of this proof of work, right? There is also the proof of stake and other methods where the energy consumption is not as high, but it's still necessary. But of course, if there is not a need for having a public blockchain for the features it has, go private, with a private blockchain, and as a result, you would solve the energy consumption problem.
Okay, so Bitcoin aside then, the skeptics reckon that a lot of the use cases we see for blockchain could be achieved quicker and more easily by using other solutions. And Eng Lim says that they're not exactly wrong.
Blockchain is not the answer for every use case. You use it where your needs, right, are met by the key features of what a blockchain is. Number one, again, a record of entire sequence of transactions going back to Genesis. Do you need that? And secondly, do you need that transparency either among everyone in the public or amongst those members in a private blockchain? Do you need that? But if you don't, in terms of transparency, where you want the opposite, right? Where you would like a centralized custodian to take care of the records and want that central custodian to control access to those records, then a blockchain is not the one for it, because it is the opposite of what you need here.
So what industries are already adopting blockchain?
The ones we work with, some are in proof of concept, and some are in early production, and some are working for regulatory acceptance. And the three industries that comes to mind immediately that we've worked with is healthcare, supply chain, and finance. And the reason for this is back to that same thing, right? Especially where you need a high integrity record of sequence of transactions going back to the beginning, so that if there are any issues, you can always do a check all the way back. In supply chain, well, guess what? The word chain is there, right? Supply chain, blockchain, right? You can see the connection here. Same medical records, right? Going back to the beginning. And financial transactions where between you sending a payment from point A to point B, you get lots of intermediaries in between. Well, a blockchain allows you to go more directly, especially if you use a public blockchain. Everyone gets a copy, and therefore your transactions get verified, point A to point B.
So now we've got an idea of what blockchain's actually good for. I wanted to explore some of the use cases for myself. So many blockchain projects are announced with great fanfare, only to peter out quietly a while later. But use cases in the supply chain are booming. And to find out more, I spoke to somebody who's actually using this, Tony Costa.
I'm the Senior Vice President and Chief Information Officer for Bumble Bee Foods. So I'm responsible for the global IT operations of our company. Been with the company for over 15 years in this capacity.
Bumble Bee Foods, for those of you not in the know, are the largest shelf-stable seafood company in North America. Thanks to our ever-expanding global market, the modern supply chain is more complicated now than ever. And that certainly applies to fish and seafood.
The biggest challenge obviously is the availability and integration of information throughout our supply chain. We deal with some of the most remote locations in the world, dealing with a variety of sophisticated and non-sophisticated suppliers. So the challenge for us is always, how do you build those relationships, but also start to integrate your collective businesses?
So why did you look towards blockchain and not just a really big Excel spreadsheet?
It started as a supply chain optimization project, like many do, right? We all want to drive efficiency and integration, but for me, it's equally important to figure out what's the business drivers and values that we're trying to accomplish here. I'm very hands-on and engaged. So 4 flights later, a 2-hour ferry ride, and the next thing I know, I'm standing in the middle of the remote fishing village of Indonesia. It wasn't until then, when I went through the supply chain and met our supply partners and our production facilities, where it kind of had this aha moment that it was bigger than just a supply chain project. It was building on that notion of not only supply chain optimization, but how do we use technology as an enabler, not only for us, but also for our supply chain partners, all the way from the fisher to the finished good processor. You quickly realize that when we were doing this project, it's as much about partnership and communication and alignment than it is about blockchain. And don't get me wrong, because we're huge proponents of blockchain. I'm a technologist at heart, right? And so I want to drive our company in a direction that embraces innovation and technology, but I also want to provide value. And finding that value is equally important to me than pushing any technology agenda.
Bumble Bee wanted to achieve a high-integrity supply chain with a tamper-proof record of each step, from ocean to plate. On his trip to Indonesia, Tony understood the kind of value that data sharing would offer to their partners throughout the supply chain. And even though it's a private blockchain, they also saw the value of sharing the data in the ledger with their customers.
All these products end up with a QR code. And so that QR code you can scan with your phone, and it tells the story of the journey of the fish, right? It will tell you where it was caught, how it was caught, fair trade certified. And then through this website, actually, we educate the consumer. We tell them about what's a typical Indonesian handline fishing journey look like. We also educate the consumer on our sustainability programs and how this is fair trade certified fish, which means we pay more for this fish. And that extra money goes into funding schools and different things within these fishing communities. So it comes full circle. And this is all just supported through a foundation called blockchain.
So what kind of training, upskilling, new tech was required for this to work?
Well, blockchain to us was all new. So on the technology level, I think that was a challenge for myself and my direct IT team, hence the partnership. But I would tell you the bigger challenge is just communicating with our business partners and even my business peers internally, the value proposition of blockchain. And I think when people try to explain it, it gets very confusing and complicated. So we learned our lesson that we didn't want to get too into the weeds when we talk about blockchain. The way I describe it is all about trust and a secure location of information, and it's immutable, so no one can tamper with it and change it. And we leave it at that. Our solution that we're providing here, it resonates with consumers. They want to know where their fish came from. They want to know it was sustainably caught. They want to know it's got high quality and it's safe. So for us, all of that kind of came into purview, and that we had to, throughout the supply chain, explain to them what's the value proposition. And what we did as well is we brought technology to these different locations that didn't have technology. We worked closely to help the NGO develop a fish processing system. And now through their funding, they're able to go out to these smaller fish processing locations and provide them with technology, with a small investment, to allow them a computer system to receive fish, track fish, produce fish, and all those kind of things. And that system fully integrates into our blockchain. So now you can see where blockchain, great, it's an enabler and it's a conduit of information, and it provides trust and a variety of different things to our consumer. But it also affords us that ability to go and work at that level with people that don't have the technology.
What's the future for this project? Is it in its final iteration, or is there grand plan for world domination?
Yeah, I tell you, I would argue we're just scratching the surface. We capture so much information. We also test all the fish that we produce out of the supply chain, and we have a link to all the lab results of those tests. And in a lot of cases, we work very closely with our retailers to provide them insights into the testing and so forth. And just expanding our partnerships throughout the world in the collaboration. We're here to be good stewards of the ocean and of the environment, and that includes our supply chain and our partners and our competitors. I'm on a number of industry panels that we are working collaboratively to, like I said, figure out the interoperability of information, because we're all, sharing a similar supply chain.
Thanks, Tony. So it sounds like blockchain, with its immutable record and transparency, is a suitable fit for a supply chain use case. And the sustainability and wider partnership benefits of the project that Tony has described really exemplify tech for good. Now, it's pretty well known that all of our organisations are producing more data than ever before, and artificial intelligence is on the rise too. And so with that, we're seeing an emerging way of using blockchain alongside artificial intelligence, something called swarm learning. Let's say I've got a hospital where I'm training a machine learning model to recognise signs of a stroke in brain imaging. But perhaps my hospital is in Scotland, where according to the last census, the population is 96% white. My model risks being pretty biased. I'd want my model to have access to patient data from around the world to make it better. But I also want to keep patient data private. Sounds like a bit of an impossible task. But England Go is working on a project that has figured out exactly how to do that.
So what we did was to use a blockchain to do this. Firstly, Hospital A would train on their own data only, no sharing of data. But periodically, a blockchain comes in and collects the learnings, not the data, but the learnings, right? And collect the learnings from all the hospitals, combine them, and then return the combined results to each hospital. So the hospitals end up only sharing the learnings and not the private patient data. After a few cycles of this, it would effectively be like as though they actually shared data and achieved good accuracy across the board. This is one actual application of a blockchain that we implemented together with a customer, a healthcare customer.
And is this what they call swarm learning?
Yes, precisely. They learn as a swarm, right? Yeah, you can look at this as another example where way out in the future, right? Drones flying, right, as a swarm. And each drone today is given instructions as to how to respond and make decisions. But in the future, they won't just be given instructions, they will be able to learn on their own. Imagine that, right? And imagine as they fly, each drone flies, it sees things, it senses things, and it learns from its environment. But you don't want drones to share the data they have collected across to other drones in the swarm, but you would like each drone in the swarm to share their learnings, so that the swarm becomes intelligent. On one hand, you want to keep the data sensed by each drone private, but on the other hand, you want those learnings from that local data to be shared across as a swarm. That's why we came up with the term swarm learning, right? The picture of a swarm of drones. But it is applicable, in the hospital environment, right? Instead of drones, you have hospitals that are collecting private patient data. But at the same time, hospitals want to share the learnings. I believe that I was told in the Hippocratic Oath, sharing of learnings, right? Teaching the next generation is part of that oath. But at the same time, to keep patient data private. Right? So this is one way of meeting that need.
Absolutely incredible stuff. So with swarm learning, blockchain is being used to share what has been learnt and not the data. And it does this without compromising privacy. And it doesn't just apply to hospitals. The approach has also found plenty of applications in the automotive and manufacturing industries. So to find out more, I called up HP's Florian Buehr.
I'm Florian. I work for the Green Lake Vertical Portfolio team as a solution architect in the area of cloud data ecosystems.
So you've been working for a while to develop use cases for blockchain in the automotive industry. So can you briefly tell us about some of the different areas that you've explored?
You can basically categorize the areas in automotive manufacturing and connected car. For connected car, we have looked into applying blockchain to vehicle and vehicle-to-everything solutions. In the automotive manufacturing, it is mostly about improving production efficiency and quality on the shop floors of manufacturers and suppliers. There is also the combination of both categories, for example, for traceability and life cycle of parts and components and tear and wear analysis use cases, where secure and immutable protocols based on blockchain can be useful. The use cases we have explored and are still exploring in more detail include decentralized automotive digital ecosystems in general. And based on this, more specifically, swarm learning to accelerate autonomous drive and driver assistance AI development, as well as swarm learning to improve the production quality in manufacturing.
So vehicle to vehicle and vehicle to anything, what's that?
That is basically connecting either different vehicles directly together, or vehicle to everything basically means connecting vehicle to a grid, for example, like a smart city with dynamic traffic guidance systems or automatic lighting. So there's lots of stuff you can actually use for vehicle to everything connectivity. It's basically looking at the vehicle as a data center rather than just a vehicle to go from A to B.
Wow. Why would you need blockchain for that? Why couldn't you just do it using, I don't know, Bluetooth?
Blockchain, basically, you can use it for a lot of things, but we use it as a community manager. So a smart city and all its vehicles is basically a community or participants of a community. And to deliver the trust in order to enable connecting and communicating together in a secure way, this is what we use blockchain for. Another reason why you would use blockchain here is, for example, that especially if you connect things together, you need software which enables you to do processing of data or doing the connectivity actually. That could be apps, but that could be little APIs or other things. And blockchain enables you to realize an automation of the deployment of the software in a decentralized way. You enter a smart city, you accept that, hey, I entered a smart city, I'd like to participate in the whole process of connectivity and digitalization as a driver, and with this driver consent, you actually execute a smart contract, and then smart city specific software can be deployed in a secure way, and the connectivity can happen in a secure way. And this is basically what you could use blockchain for.
Now, for a good use case, Florian says you need an achievable goal. With one of his customers, a laser machine vendor, they settled on the objective of reducing the scrap rate of one of their production steps.
It could be a weld, it could be a laser cutting, it could be different precision steps, which just result in a higher amount of scrap, could be, for example, 40%. Because of production quality, production circumstances, and the actual production step just does not fit perfectly together. And in order to improve that, you could basically apply machine learning in order to learn better what are the different circumstances, what are all these variances you have to deal with. And that basically helps the machine vendor, first of all, to create better machines eventually, or actually in the production process to either help machine operators to adjust machine parameters better to the circumstances, but potentially also to automatically adjust machine parameters. So this is basically what you could enable with that.
So the manufacturer has all of these machines. They want to learn from all these machines. So do they just have one big centralized database where all of these machines dial home and they can send software updates out to all these different companies that have got these machines? Is that what they have? Is that how they do it?
No, that is not how they do it. Actually, how they have to do it is basically currently most of them create lab environments. So a machine vendor creates its own little lab environment and tries to simulate the real world production. But that means that this is only simulated data. It's no real world data, and it's a limited data set you train your machine learning models on. The reason why they have to do it this way is because generally manufacturers do not share their data. Either because it's very sensitive to them, it is intellectual property, it is telling too much about their production process and stuff like that, or if not even or it is their competitive advantage compared to other manufacturers using the same welding machine or the same cutting machine.
Just like the patient data in the hospital, these manufacturers don't want to share. It's another case for the swarm.
Swarm learning is basically bringing the machine learning model to the data and not the other way around. So basically we keep the data where it is. So if you have, if you're a machine vendor and you have 5, 10 or 20 or I don't know how many customers all using the very same machine model, you basically bring the machine learning model for the training on their real world production data to their shop floors, and not the data from the shop floors to a central place where you train the machine learning model on. So the difference basically is that data does not have to be moved and it does not have to be duplicated. Basically, you move the logic, you move the compute to the data. And that is very beneficial because it really breaks open traditional silos based on data, maintaining the data privacy and the data sovereignty of the manufacturers.
So from a kind of customer and from a customer's customer perspective, is there lots of work they have to do to kind of keep this up and running and maintain it? Is there lots of computing overhead for the people operating it? How does it work?
Well, I start with the last one you said. A computing overhead for the machine itself will certainly be there. So a machine always has to do its production process first. So this is why we use things like digital twins, so that we do not use compute capacity of the machine and take this compute capacity away from their actual production process. So that's one thing. Everything else, is there from a customer experience a large amount of effort? No. We try to achieve a high level of automation. So if a machine is supposed to join a swarm, or if a customer wants to join a swarm with all its machines, we basically try to do the whole deployment of the software, of the HPE Swarm Learning Library software, as well as all the software which basically enables the decentralization, the participating in a certain swarm for a certain machine learning model, for a certain machine model, that we do this based on smart contracts and blockchain mechanisms in a highly automated way, so that IT operations is hardly involved at all.
There are often blockchain projects, they get announced, and then they seem to disappear into obscurity. Why do you think that is?
Well, it's just my personal opinion, but I think that many blockchain projects are announced for the sake of using blockchain. We started with architecture goals and objectives, and then derived design decisions and implementation decisions as implications to achieve these goals. So as a matter of fact, you do not come in with an implementation decision, let's use blockchain first, but you try to basically identify what do I want to achieve, and then blockchain can or cannot be of a functional purpose. And that results in a real world and in a working implementation, rather than in an implementation which, once you have basically brought it up to an, I don't know, prototype state, and then you install it, you find out it won't work, it won't scale, or it won't perform. And that is basically the difference why we are perfectly confident that our solution, well, it works and that it will scale. And that may or may not be the reason why other blockchain projects never see daylight.
Do you think there's a lot of kind of using technology for technology's sake?
Absolutely. Absolutely. Some people believe in blockchain and really think it will change the IT. And other people say it's exactly the opposite. It won't change anything. It doesn't add any real value to it. And you basically have two different parties, the believers and the skeptics. And I'm an agnostic. I don't believe in either or. I look at from an architectural point of view and from a methodology point of view, start with value proposition. And based on the value proposition, you will find out whether blockchain can or cannot be a pain reliever or a gain creator for your value chain. It might very well be the case that blockchain does not make any sense for you.
Thanks, Florian. So, blockchain and swarm learning. It's another good use case, and more importantly, it's an appropriate use case. Blockchain isn't right for everything, and that's certainly something that Englund Go, despite being a blockchain believer, also agrees with.
The quick answer to your question is one where, what are your needs, right? Not every problem needs to be solved by a public blockchain. In the same way, me as CTO for AI at HPE, I always tell customers and engineers I work with, not every problem needs to be solved by a machine learning to be artificially intelligent. If rules and analytics work, we should stick with rules and analytics until you think that in the long run or now it doesn't work. And you would use the appropriate tool for your needs. And blockchain has a very specific capability. And if you need those capabilities, you would use it. In many records of sequence of transactions, you would like to be able to trace it back to the origin. Different levels of transparency. A public blockchain, full transparency. And in certain financial transactions like in Bitcoin and Ethereum, you like that, you want that. And of course, if you don't need it at all, you go with the central custodian approach. And it also gives you one degree lesser transparency, and that is with a private blockchain, where membership is required. And you see that in supply chain, in other financial transactions, and in healthcare. And if you don't need it to even that extent, you would use what we traditionally use, which is a centralized ledger.
Okay, so how do you think blockchain will mature over the next decade or so?
I believe it will grow tremendously. I believe there are many transactions that's going on out there that will find these features valuable. And as such, I believe the use of blockchain will grow. The key thing is that it takes some time to go from something that is proof of concept, that we have proven as a concept it works, to production, and then ultimately, especially in transactions that are regulated, to get acceptance at the regulatory level. And that's what many of the customers are working on right now.
And in which industries do you think we'll see more widespread adoption over the next few years?
I think the general answer is as the edge computing and Internet of Things grow, you will see the need for this more and more. By the year 2025, there will be 55 billion connected devices out there. Now, when you have so many devices, it's becoming more and more insurmountable to have central control of all these all the time. You may have to figure out a way to do hierarchical control in a hierarchy, but blockchain allows you to do it in an even more decentralized way. So as such, I believe in general, Internet of Things will be the key to the proliferation of blockchain.
decentralized banking, supply chain traceability, the possibility of international collaborative healthcare projects. The sky is the limit. Blockchain has the potential to be really revolutionary, at least if it's the right fit for your use case. It's easy to get swept up in the hype, but using tech for tech's sake is pointless at best, and it's definitely a waste of money. But you know what isn't a waste of money? The hottest new cryptocurrency, Birdcoin. Now offering incredible returns. You better get those diamond hands out and hold it to the moon. Terms and conditions apply. Birdcoin takes no responsibility for partial or full losses incurred. Birdcoin is not subject to protections or insurance provided by the Federal Deposit Insurance Corporation. By purchasing Birdcoin, you consent to us accessing, processing, and retaining any personal information you provide to us for the purpose of us providing Birdcoin services. Birdcoin is a totally made-up cryptocurrency, but sometimes it's fun to record these really, really fast voice events. You have been listening to Technology Untangled. I'm Michael Bird, and a huge thanks to today's guests, Eng-Lim Goh, Tony Costa, and Florian Buehr. And you can find more information in the show notes. This episode was written, produced, and edited by Isabel Pollard, with sound design and mixing by Alex Bennett, and production support from Harry Morton, Alex Podmore, and Tom Clark. Technology Untangled is a Lower Street production for Hewlett-Packard Enterprise. Thank you so much for tuning in, and we'll see you next time.